So there you go, an outlet wired up with essentially no tools. This is really just incrementally making DIY and electrical stuff so much easier. Let's face it, things like electrical, plumbing, and HVAC have kind of always been an exclusive and an elusive club with a lot of products and tools designed around people who do this every day for a living. What's really cool though is the internet is changing the way people like us build things. We've built our entire home and we've done a lot of DIY, and it's nice when companies see that and they start making products easier to use for people like you and I. I have something really cool I want to show you that's going to make life a little bit easier on your next project. Before we get started, I want you to know that this video is not sponsored by any product company or any other company, and the opinions in this video, they're all mine. If you're unsure when you're doing electrical work, it's probably best to just stop and call a licensed electrician. Okay, let's dive in. In the past, if you were just maybe doing a small outlet upgrade, like maybe you had an outlet like this that's kind of just grungy, dingy, and all covered in random paint, or maybe you have an outlet that just stops working and you want to switch it out, maybe that's the problem. You really only had two basic options. You had a cheap outlet like this with a push-in connector, we'll talk about that in a second, or you had this type of outlet with a screw on the side and you had to do some finagling to get the screw to fit. Those were basically the only two options you have, but there's a new option out there. So in the past, you took an outlet out maybe to replace it, or maybe you're just doing some outlet upgrades, and you probably found one of two things. You either found an outlet like this and it had a wire that was pushed into one of these push-in terminals like this, in which case it's probably a 15 amp outlet. And the bad news about that type of thing is that even though these are rated, the general consensus among a lot of people, which makes me think this is not just a fly-by-night opinion, is that these are dangerous. I mean, there's just clearly something going on here, and I understand that there's a reason that they exist, and there's a reason that they're there, okay, and they're rated, and so technically they're safe, but there seems to be kind of a general consensus that these are not that great. Okay, so you probably found that, or maybe you find this other situation here, which is these screw terminals, and you end up having a wire that's kind of wrapped around like this, and you have to unscrew it, and it's kind of a gangly mess, and it's hard to work with. And there's always the risk that you overstrip the wire or understrip the wire, and it's just a lot of work, right? So those are the two kind of conditions that you're probably most likely to see if you're trying to do some outlet work. For a while now, there's been this kind of trend, and it's somewhat of an internet trend a little bit, to move away from wire nuts. And wire nuts, there's nothing inherently wrong with them. They still work, obviously. So let's say you have two wires and you want to connect them. You might try to bring the two wires together very tightly, and then you would apply your wire nut. And of course, if you're doing it right, you're using the right size wire nut, and you're using a set of pliers, and you're getting the appropriate amount of torque, and then you're doing a test to make sure that everything's tight, because the last thing you want to do is have one wire slide out, or maybe the most insidious is to have a poor connection. So you have all these problems, right? Well, we're getting away from that, and we're moving to what's called a lever nut, which is a newer technology. And basically it's this little device, and it has little levers that you simply move up, and it's very easy to apply the wire into the slot here. And then all we need to do is make sure that the wire is fully seated and then move the nut down. And there we go. We have a very secure connection. There's no twisting, no pliers, and essentially no tools. Once the wire is stripped, move the nut up, and there you go. What's super exciting is that someone has seen the future and they've applied this thinking and this technology to an outlet. So this company, Leviton, has taken this concept of the lever nut and they've applied it to a traditional outlet, giving us a whole new way of dealing with changing outlets out. You could, in theory, come in with essentially no major tools and you can install an outlet. You guessed it, they've put the lever nut on the side of the outlet, meaning we can just slide the wire in, boom, and everything is connected. Now, we want to go back here a little bit and take a moment to think about what's the main difference between these two outlets. We talked about the push-in connector being kind of a question mark in a lot of people's minds, and why is that maybe deemed, generally speaking, not a great idea? Unsafe, if you want to call it that, because there's a lot of burned outlets out there. And the reason for that is it's not clear whether the wire is making a really good connection. So what's the real fundamental difference here when we're basically using a similar idea? We're basically pushing the wire in and making a connection. The big difference in my mind is that the connection made by this lever nut is positive. It's something we can almost visually inspect also. Notice how the nut is clear, and so we can see if we've got good penetration with the wire, and we can also give it a good physical test. And I'll tell you, these are very secure. They're impressive for what they are. For such a small device, the amount of leverage that this little lever creates is impressive. On the other hand, this outlet with the push-in connector, if you just work that wire a little bit, guess what? Out it comes. And again, I'm not saying that these are not safe. What I am saying is that it's interesting that the technology is seemingly a very small shift, and yet it's impressive in what it achieves. So if we can apply this technology to an outlet, it feels like we've made a very big leap forward in ease and in safety. If you're enjoying this video, go ahead and give it a thumbs up, and please share it. Help us share these cool DIY and new products with other people. All right, back to the video. There's another very clear, notable difference here that it almost makes me laugh, to be honest with you. We recently did a video on common wiring mistakes that DIYers are making, and you can actually understand this mistake. It's what's called reverse polarity. So you have a gold screw on a traditional outlet and a silver screw, and honestly, it's pretty easy to make a mistake and put the wrong wire on the wrong side. If this traditional outlet, were wired correctly, the neutral, which in almost all cases is white, would go on the silver terminal, and the black wire would go on the gold terminal. Got that? Black goes on gold, white goes on silver. You know, there's got to be a reason, again, why that is, and it's one of those things that's just how it's kind of always been in the industry, I'm guessing. And so you can understand why a DIYer might accidentally put the wrong wire on the wrong side. Of course, on most outlets, there is a reminder here, so there is a way to make sure that you get it right. But how intuitive is it that we make an outlet where black is black and white is white? I mean, come on, that's such a seemingly simple change that's just going to improve safety overall, especially for DIY people. And then, of course, the kind of generally accepted ground color is green. But no normal person is probably going to confuse white for green or black for green, right? And so this is a simple change that makes this outlet just make that much more sense. I'm guessing because, you know, even with something like this, we cannot see inside of it like the lever nut. And so we want to make sure that we're doing the job correctly, right? So this outlet still has a strip gauge right here in the corner. And what that's for is basically you can lay the wire in here and it gives you the proper depth. And the important element here is that we don't overstrip the wire, and so then the wires would be sticking out the back exposed, that we don't understrip the wire, and that we slide it in there and make the connection, and inadvertently the lever nut is actually clamping down on the insulation, and wouldn't you know it, the wire is not making a good connection, and we put ourselves in a dangerous position. So even though this has been a simplified technology, the color, the technique, it's good to still follow the basic principles, which is making sure that you have the strip gauge correct. And that's true on every single outlet, and they include one on this one. So let's go ahead and give it a try here. So we can just go ahead and make a measurement. I'm just going to use my finger here and say that that's the ideal strip dimension. And I'm going to use a set of specialized pliers here to strip this back so that I don't make damage to the conductor itself. Okay, and we've got our wire. And now we can simply move this nut up and install the wire. Feels really good. And lock the nut down. Feels very nice. Let's give it some pulls. Oh, you know what? Oh, well, see, that's kind of interesting. We were actually able to pull that out pretty easily. And I don't really see, there's really not much jaw marking on the wire. So I would say that's kind of interesting. I wouldn't have expected that. Based on my experience with the lever nuts, I would have expected this to be almost impossible to pull out. So let's try that again. So we've got the wire in there. We know we're at the right strip depth. Boy, it definitely comes out easy. Look at that. Pretty steady pull. So, that's definitely a major question mark in my mind. All right, well, I guess that's kind of a step in the wrong direction, I feel. And you know what's interesting is that this is actually number 12 wire, which would normally be rated for a 20 amp circuit. And as it is, I believe this is probably a function of, although these are probably rated higher than this outlet is rated at 15 amps. And that's the maximum that it's allowed to be installed on, the circuit size. And that may be a function of these lever nut style connectors. I know that's true on, I think, most of these push-in style connectors. These these are usually limited to 15 amps also. And so ironically, you know, sometimes these outlets can be installed in kitchens and things like that, but you know, obviously putting them in a position on accident where the circuit is rated higher than that, like say in a garage or something, would probably be a very bad idea. You know, there's a reason they rate these the way they do, and probably good to follow that rating. So, you know, that's kind of interesting. I'm not really impressed by that. Of course, obviously, the question isn't whether the wire pulls out or not, because once something's bolted into the wall, it's probably not going to come out. But that said, it does, you know, leave that question mark in your mind about the quality of the connection. Although, going back to this lever nut, the quality of the connection here is far more positive than it is on the back of these blue outlets. So I guess it's something that we'll have to kind of let time pass. A few of us are going to have to try these outlets and kind of see how they actually work. Well, guys, that didn't go as planned. I mean, you got to see this at the same time I did. I wasn't expecting that, honestly. You know, based on everything I know about the lever nut, I had the same level of expectations with this outlet. And, you know, does it really damage my confidence in the outlet? No, I wouldn't say it does. You know, once the outlet's installed, I just don't see that, you know, pulling out is going to be a major issue. I think the reason that these lower, seemingly lower quality outlets with the push-in style connectors worry me is they just have a bad reputation, and for now these don't have that reputation. And because they're just a different technology, I feel like maybe I have more faith in what we're looking at here than I do in these. Just these scare me to death, especially when people use the push-in style. And maybe there's the other side, that this just feels like a higher quality product overall. Maybe it's just looks, but it definitely feels higher quality. And then because I have so much faith in these lever nuts, we're using them quite a bit. You know, they're just such a simple technology that solves an obvious problem. I guess it wouldn't stop me from installing these. We'll probably look for a few places to put them in because it just makes sense. And you know, if you needed to change one, or just from a pure installation or labor perspective, it seems like a win in my book. Okay, let's just do a test wire up and we'll just see how easy this is. So let's go ahead and flip up all the little tabs here, the levers. Okay, and again, super intuitive. We put the black wire on the black side, the white wire on the white side, and green. In case you guys don't know, when copper oxidizes, it turns green, and maybe that's why green is to be assumed that's the ground, but anyway, that's the way it is. So now we can just flip the nuts down, and that's all wired up. That's it. That's so simple, and then you can simply put it back in the box, put your cover plate back on, and away you go. Now we got a little bit different situation here that you might need to think about, and that's what if you have more than one wire coming in or going out. So you've got another black wire and another white wire here, okay, but you've got a problem. You've got two grounds, and guess what? You're not going to put a second ground wire in here, right? Well, the cool thing about this is you can't screw this up, unlike other outlets where you could hypothetically get a second wire on a single screw. You're not getting two wires in there, so that's a good thing. So there's a really simple solution. So what you would do is you would have a pigtail out here, and you can just bring these three wires together using yet another lever nut, which is, again, simple and reliable. So we've got our wire or a lever nut there. We've got three wires in there, and we can just flip all those levers down. And now we have safely extended the ground that's on this outlet to include another wire. So there you go, an outlet wired up with essentially no tools. We didn't have to use anything to screw down here, no wire nuts here with a set of pliers to crank everything down. This is really just incrementally making DIY and electrical stuff so much easier. So then to change this outlet out, simply flip all the nuts up and out come the wires. And you can put a new outlet in and be done in just a matter of maybe 5 minutes or less. You know, I just noticed a feature of this outlet that hadn't crossed my mind, but it would have as soon as I tried to wire up a switched outlet. In a lot of homes, it's very common to put a switch on the top outlet so that if you wanted to plug a light, say, into that, and then you have a switch to operate it, what you're actually operating is this top outlet. But the bottom one actually is an outlet where you could plug in a vacuum cleaner or your smartphone or whatever. And so the way that happens is over here on the side of the outlet, they actually provide a small ear or a tab that gets broken. And so what it does is it allows you to wire two different circuits into the back. So you have the outlet circuit, which is providing steady power, and then you have the lighting circuit over here with the switch on it. So this outlet acts like two completely different circuits. The way that's done is right here in the middle of this outlet it looks like they have a little ear here that you bend up to expose this little tab. Inside there's just a little tiny tab, and in this case it's copper. And what you would do is bend and break that tab. What that does is it creates a connection between the upper and the lower socket. When you break that tab, now they act independently. Of course, once it's broken, you can't ever put it back. You would need to replace the outlet. But the way they've solved that problem is they have this little ear that sticks down and just protects that thing from a short against the box or an exposed wire. A traditional outlet has this little ear right here between the two, and it's the same thing. You can simply bend this a few times and it will simply snap off, and then that makes these two work independently. So that's how they've solved that issue with this outlet. There's another kind of cool benefit that I see happening here. Notice how the side of the outlet is nothing but plastic. Where a traditional outlet, we have exposed metal and exposed wire. You know, it's not uncommon when people are trying to wire up two outlets like this you'll see people trying to use things like electrical tape, and they'll wrap it around the outside of the outlet here. And the reason for that is sometimes in the box things can get a little bit tight, and what you wouldn't want is anything touching, of course. That would be probably problematic. And so what you'll see people do is take some electrical tape and they'll go around the outside of this outlet, and that just provides a nice insulative barrier. Probably, you know, in most cases it works pretty good. And especially if you're working in a box and maybe you're one of those people that just, you know, wants a little extra layer of safety and just a little bit more comfort. So I see that if you had two of these outlets here, guess what? It can't happen, because you basically have two pieces of plastic which are naturally insulative, and they're just not going to have that problem. And so two outlets in a box is no big deal. No need to wrap with electrical tape or take any additional steps to keep things from touching like they shouldn't in a box. And there's another small innovative idea being used here. Have you guys ever seen or had this issue where you're trying to put two outlets in and for some reason they kind of end up wonky or a little bit weird? Because obviously there's play in there, right, to make sure that the cover plate fits. And you know, sometimes just the amount of wire in a box makes two outlets want to push apart or be kind of weird. They're actually forward thinking here. They've innovated this tongue and groove type system. If you look here at the top of the outlet, you'll see this small key place right here and a small groove on the other side, so that when you install these outlets, they actually lock into each other and they become a matched pair, and they cannot move once they're locked in. Now, of course, there's play back and forth, and there's, you know, rotation still available through the screw system, but that tongue and groove makes the two outlets line up easily, and then putting the cover plate on isn't such a bear. So it looks to me like they've really thought through some of the most common problems or frustrations that we have as DIY electricians, and try to make life a little bit easier. There's one last feature that is just wonderful on pretty much all modern outlets, although it is still possible to buy outlets as exhibited here. I bought this outlet just the other day, and this outlet does not have the features that this one has. It's a tamper resistant or child safety feature, and what it does is it's basically got a small shutter inside here that keeps people from plugging things in that shouldn't be plugged in, like the proverbial fork, right, that we all kind of laugh about as kids. You're not supposed to be able to plug things into this outlet that aren't supposed to be in there. And it's a small shutter system that keeps things from going in when they shouldn't be in there. So maybe a little one gets a hold of the kitchen knife or something here, and you know, they're trying to do things kids do. This keeps that from going in and creating a safety hazard. That small system, though, it's a small price to pay, you know, to have a little bit of safety in your home. But then notice something that's intended to be plugged in plugs in just fine. These are becoming code in obviously construction for obvious reasons. It's just for safety, and they can be a little problematic sometimes. Maybe sometimes you have a plug that's a little bit wonky and it doesn't want to go in, but it's a small price to pay to have a little bit of extra safety in the house. And it's nice to see that they've included that with this outlet. So overall, I'm super excited about this. Maybe not this exact outlet specifically, but really the trend here is giving DIYers and homeowners more options. Of course, electricians are probably going to be a little grumpy about this maybe. Some will say, hey, that's amazing, makes my life easier. And other people will reject it saying, well, that's not good. A homeowner could do their own work and they don't need me anymore. You know, that's kind of already happening anyway. What I'd really like to see here is maybe this technology moving up. Light switches, I'm sure is coming if I don't already know about it. Maybe a 20 amp outlet would be amazing. This one's rated at 15. And so we'd like to see something with a higher amperage rating because 20 amps are pretty much becoming the norm. I mean, 15 amp outlets, I don't know. I mean, they're out there. And I just don't see most people who are really DIYing, who care at all, doing that type of work. What does something like this cost? Right now, this is in the mid $3 range. Is that expensive? No. In fact, a quality outlet that is a 20 amp outlet is probably running somewhere around $2.50. So you're looking at about $1 for the convenience. So this hasn't really increased the cost of doing your own work either. Have you guys used this yet? Have you done a project with these? Do you have any experience with them? How do you like them? Let us know in the comments below. And if you really enjoyed this video and you want more DIY electrical tips, tricks, ideas, and product comparisons, be sure to subscribe and share this video. It really does help reach more people, and maybe more people can find out about really cool DIY products like this. Thanks for watching. We'll see you on the next one.